20 years ago, building internet scale applications was incredibly hard. You just not had to build the software, but then you also had to think about how to manage it, deploy it on-prem. And then Google, Amazon developed a great bunch of technologies which helped a lot of companies over the next 20 years being ready to be able to deploy them on cloud. They said cloud is simple. Create an account, and then woof, you have a bunch of technologies readily available at the click of a button, ready to be deployed. It works. It really, really works. We have so many different companies today not trying to get on-prem. Today, most of the modern companies today come onto the cloud. They also said cloud saves money, right? Like move over from on-prem. It's a lot cheaper. And you know what? We ended up spending over $150 million on an annual spend. Today, I'm going to talk about how we reversed this trend, share our journey of how we moved from about north of $100 million annual spends to $20 million, and how some of the technologies that we discussed today helped us make that journey. Hi, I'm Arya. I've been tinkering code for the last 20 years, but I also enjoy watching sports, avid sports enthusiast. And I'm a father to a lovely 5-year-old daughter, so who's missing me right now because I came all over away from India. Cool. So a transformation journey, right? ShareChat, and I'll talk about what the app does in a bit, is a very high-scale application, and that led to a huge, as we started scaling up, and we started scaling to hundreds of millions of users on a monthly basis, our cloud spends, we're a digital platform, native platform, and our cloud spends really ballooned up. Then, so now, as we made that journey from $150 million to $120 million, there were key changes that we had to do in the organization, and I'll talk about them in a bit, right? What were the cultural foundations that we had to build? Change the core DNA on how we operate to be able to make this journey. What were the different technical improvements, technologies, excellence, technology things that we had to implement, make, and absorb so that we could do this journey? And then most importantly, what do we do? What does one need to do to kind of make it sustainable? Because it's not a one-time thing. ShareChat today, over its app ecosystem, which is ShareChat, Moj, Vibely, and QuickTV, caters to about 200 million monthly active users. We are the third largest digital platform in the country, probably in the top, 7 or 10 in the world. At that scale, it means, it's obvious, right, what happens. So what does our app do, right? So ShareChat, India, is a vast country, 1.4 billion people. We have over 25 different primary languages spoken in the country. Right? So what ShareChat enabled is people to consume content in the language of their choice. You didn't have to rely on another language to consume content and share it with your friends. On ShareChat, when someone comes in, they discover content and then share that in their WhatsApp family groups and talk about it. For example, whenever we have festivals, and we have a bunch of them in India, it's one of the first platforms for anyone to come and consume relevant content of that festival, something that is trending right now in the country, consume that content, and then share it across in different, in say, WhatsApp or in other places. We have Moj, which is a short video platform. TikTok does not run in India, and we are therefore think of it like the Moj app is the TikTok of India. So so through TikTok, we have enabled a bunch of influencers who are showcasing their creativity and also, by the way, earning a livelihood through our platform. We have a huge bunch of monetized creators earning on our platform through the content that they are creating. We realized a new format of short videos, and with that, we launched QuickTV. QuickTV is short videos, but in an episodic manner. So now with attention spans going dramatically down, people don't want to consume 1.5 hours of a Netflix movie in one shot. People innately love drama. So short video drama is what is really catching up. In fact, in the last 2-3 months that we have launched, we have seen tremendous growth. Our time spent has increased by 20-25%, which is huge on a social media platform. Just on the fact that people want to consume not just a random bunch of content across different genres, but a content which has some stitching together, which has a storyline, and which kind of brings them back to the platform to consume that content. We also have a digital consultation app called Vibely. India, there are a lot of in India, there are a lot of societal taboos to talk about the challenges that you're facing personally. So through our platform, we have enabled people to talk about them with someone who's kind of a stranger. These are not like professional services, but this is more like someone giving an ear to you, listening to you, so that you could talk about it. And maybe with someone sharing their own personal experiences, maybe lend a helping hand or lend a helping ear to help them come through those problems that they're facing. So this is basically the kind of ecosystem that we have developed over the last 10 years. And with that, and at India scale, nothing starts at 100K active users. When something starts trending up, immediately you'll find that as soon as you start hitting product market fit, immediately it'll come to like millions of users thronging to the platform. In the weeks after TikTok got banned in India, we had a 50% week-on-week growth. Week-on-week, we were growing at 50%. We went from about 1 million daily active users to about 12 million monthly active users in a matter of days. So obviously, when you have to build this entire complicated system of someone creating content, then distributing it to a vast majority of users, it's a very complex, and then analytics and a bunch of things, right? So then it means that that's the kind of infrastructure that is required to serve that. We have services serving a billion QPS. We have petabytes of data being transferred daily over our CDN networks. We have hundreds of thousands of codes running on an hourly basis as things scale up and scale down. Unfortunately, we don't have 100,000 engineers like Meta or Google over a huge majority of time. People who have really gone ahead and built technologies and served at scale. So, quick show of hands. What do you think is the average cloud wastage in when someone runs on cloud? 20%? Show of hands. 40%? Okay, few. 60%? Okay, maybe one or two. Okay. So keep that in mind, the cloud wastage, right? So you think when there is wastage, there is an opportunity to optimize. So typically, like very easy optimization to do, and which most of the companies do, is maybe about 20%. You know the easy things to optimize, and you'll go ahead and quickly optimize them. Gartner typically, like in one of their research papers, they shared that it's kind of possible to raise this benchmark to about say 30-35% with some automated intelligence. So you build in some pieces of things together which runs on a continual basis, and you bump up the overall optimization. In best case scenario, right, you maybe stretch it to about 50%. But it takes an extraordinary amount of effort to like really go past this. And this is what we have achieved over the last like few months of working, right? We came down by about 70-80%. Oh, I don't have, okay. There was a clicker here, sorry. Okay. So I just wanted to give, before I go into the details of how we went about it, I wanted to give a few, like a very short summary of what all things we had to optimize on. It's not just one thing. There are many different crumbs that needs to be pieced together to achieve this sort of optimization. And that's true for like any enterprise, any startup that is trying to scale up, right? It's not just one thing. You need to look at it at multiple different things. So across our entire journey, obviously we went after the low-hanging fruits first, right? Like things that were overly provisioned, not monitored well, like get them to provision correctly, etc. We are a content-heavy company. So it kind of made sense to kind of focus on CDNs and video optimization. So did a bunch of transcoding optimizations and working with multiple, like built a multi-CDN framework where we could kind of run any our content through multiple different CDN networks and thus be able to get efficiencies in cost in the costing of their CDN pricing, right? We did a bunch of Kubernetes optimizations. Anyone who has deployed anything on production will probably be using Kubernetes today. And there are things that are like very, very easy to kind of, I mean, it gets incredibly complicated. It's great technology, but it also gets incredibly complicated to run it in an optimized manner. And then you have the databases, you have your managed solutions, which works amazing. Like if you use Spanner or RDS or BigQuery, these are great technologies built amazingly well, but it costs a bomb, right? And that is where you start kind of understanding the pinch. Networking is one of the layers which it's so very difficult to kind of understand what's happening. Which service is egressing inter-zone, inter-region. It's the observability today is anyways very, very hard. And again, there is no specific solution that works out of the box to kind of solve for this. And finally, like you need to think about your data policies, your storage policies. Not everything needs to be like retained over two different regions because it just was like that was a configuration and you just switched it on, right? So you think about retention policies, you need to think about what is critical for the data. So the point being that the optimization journeys are not a single focused thing. It's a multi-layered problem statement and needs incredible amount of energy and focus to get it right. But before I get into the technical aspects, I actually wanted to cover today a lot more on the cultural aspects, which I feel is an equally more important thing for companies that want to kind of run in an optimized manner to focus upon. So the first one, right? Success lies in building observability. Today, when we deploy code, what is the first thing that we do apart from writing code? We write things to observe it, right? We put metering on it, we put logs, but we never did the same for cost. We just deployed it and hoped that it incurs some cost and some finance guy will think about it. Observed systems are most cost effective, and I'll get into details of all these things. Why observed system is more cost effective than an unobserved system. Cost constraints drive innovation. It might sound counterintuitive, like if you were constraining something, then how will you get innovation? And I'll come to why it drives innovation. And then unit economics. What is unit economics and why does that play a significant role in the cost optimization journey? So yeah, the first one. Success lies in building observability, right? So when in the cloud world, right? Just get me here. Yep. Some of the things are very easy to observe. For example, if you're using cloud logging or like the equivalent of that in AWS, logging costs are easy to observe. You just go there and you can see you have a section of logging costs and you will understand your logging costs. So if you're using something like Datadog, you will see the cost in the Datadog portal. API usage costs is easy to monitor and build observability on because you are able to kind of translate the cost of running an application in the environment. But then it starts getting incredibly tougher to start building observability for cost, right? Slow running code. When things go out of hand, like which portion of your architecture was the problem in spiraling the cost? When we work with managed services, we don't get a lot of attribution within them. For example, you might be using shared databases, or for example, in Spanner, you typically sometimes you pull in a bunch of tables on the same database. Which table is causing the issue? Which table is causing this increase in cost? It's not very trivial to understand. Wastage is incredibly hard to understand. There is no direct observability provided by any of the cloud providers on how much wastage you are incurring, right? So these are some things that you have to start like putting specific focus on if you want to kind of go on that on the cost optimization. And then don't even get me started on networking. Cloud usage will report something and the cost will be something else. And if you ask the cloud guys, they'll have no answer. They will point you to an aggregated view of cloud usage, but they'll never be able to translate that to the actual cost that you are incurring. So, so when we started building this, the first thing that we need, and which was probably the most logical step as well, is to not just do the standard cost observability on what the cloud provider provides, because that does not give you the state of the system. What we did is we went ahead and tagged all our infrastructure on various different components, but I think these were the most critical tags. Environment, like production versus staging versus development. Which component of a particular service? For example, are you using a database, or are you using a messaging queue? Are you using like where it's a job, it's service, so all these things were different components of a service. And then multiple different services, we created something called a pod, which is basically a small function within a large team. And then multiple teams make up a business unit. So as we have 4 different tabs, we have 4 different business units. Each business unit has a different set of teams, and then pods between them, and then so it all becomes like a funnel. Now the thing is that before we built this, and this is like one of the actual screenshots of our cost kept increasing. And we had no real answer to which particular service, team, pod is causing the increase in cost. And as soon as we rolled out our first version of our cost observability, we immediately saw actionable things to get done. We had real action items for teams to perform, to look into. And we could see a sharp dip in the cost as soon as we built the first set of observability dashboards for the company on cost, which is more than what you get out of, say, standard cloud provided cost dashboards. Second principle, observed system is a more cost-effective one. Why do we say that? Generally, so far, the focus, like maybe a few years ago, was cost is primarily a finance concern, not really a technology concern, and which works okay if you have like millions of dollars. I don't know, like OpenAI has committed $300 billion to Oracle, and maybe they have that kind of money. But not every company in the world has that kind of money, right? Not every company that is trying to make a profitable business today can afford to live in the world where cost is not a technology problem, because it's not infinite. I mean, compute is infinite probably in cloud, like not truly infinite, but like truly scalable. But the money in your wallet is not probably infinite. At some point in time, someone will come to you and say that, hey, you know what? This is not a sustainable business. So therefore, as soon as you build observability, you're taking a step to making it more effective. You have to train engineers on the cost of code. When you write a function, and it could be like the most ugly written function consuming a lot of CPU, if there is no scale, no one really cares about it. A service running at 1 QPS, taking 1 core, probably no one really cares about it. But when that service starts seeing 100,000 requests per second, that piece of bad code has really exacerbated your problem, right? So you have to train engineers on why the cost of code is important. And therefore, when they have a observable system to observe, they naturally, no one wants to write like bad code by default, right? But then once you give them the view, and that's where like debugging has always been one of the core tools that we empower an engineer with, right? So we are focused on application debugging. We never focus on cost debugging. And therefore, like tying in with the first principle, you build the cost observability dashboard, immediately the engineers becomes more effective. Okay. Yeah. So another important thing is that it is incredibly hard to predict the cost of something that you're building. You may run some simulations in your staging environment, but as Orid was saying, that it's impossible to kind of predict the workload that will eventually arrive. It may not be consistent with what you saw in staging. So this, for us, what we realize is there is no point in trying in making this prediction that hey, this particular service will incur X amount of dollars when it goes to production. So instead of wasting our time on trying and getting engineers to predict the cost, we build the observability part of our core system so that they as soon as they ship it, they start the cost flaring up. They can quickly roll it back or scale down the experiment so that they could get time to kind of fine tune it. Which brings me to the third principle. Cost constraints drive innovation, which might sound counterintuitive. Your engineers already have a bunch of problem statements. They have to deliver shipment, the next feature yesterday, not tomorrow. Now you're asking them to also write optimized code for it. Like, which product manager, engineering manager will now put their hands up and say, you know what, this we will do. But truth is that constraints drive innovation. The first moon lander, it had guessed like how many bytes of memory. It had few kilobytes of memory. My Whoop today probably has thousands of more, right? So if you could build something that can land on moon on such a constrained memory, then it makes sense that as soon as you start constraining engineers, they themselves get challenged, and then they build out the right solutions for the same. And that's why you have all these technologies that have come today, because they didn't just accept that, hey, you know what, throwing hardware is the solution to all problems, right? They worked with the theory of constraints. There is limited infrastructure. There is things that needs to be done in an efficient manner, and therefore let's innovate, right? And this is what all engineers do. This is what we all love doing. We love getting challenged. And when therefore you put cost constraints into your feature development, that is when true innovation starts happening. So for example, the latest Rexes that we built, we didn't say that you have insane amount of money to build the Rexes system. Rexes is recommendation system, right? So we gave them a budget that this is like you to build the next ranker, you have like few $100,000, but that's about it. So you plan it out, but then deliver, right? So as soon as we did that, we were able to meet both the cost constraint and the product objectives. So don't for a moment think that you should not challenge your engineering team. You should. And not just you as an individual should get challenged and think about how is this the most efficient system that I am writing? Is this the most efficient use of technology that I am using? If not, think more. So make cost a non-functional requirement, just like you make performance and reliability are a key non-functional requirement in your systems. So we've kept on talking about cost, but the true statement is that cost is a very horrible metric. It lacks context, right? So is X million dollars good or bad, right? How do we know? Like, if you have spent X amount of dollars, is that a good thing or a bad thing, right? We don't know, right? So how do you answer that? Your finance or management does not want to hear things like, hey, you know what, like interzone cost spiked up. I'm really sorry. Like, they don't understand Kubernetes. They don't understand like NIZD or interzone or RDS or whatever that you're using. What does engineers understand? They understand cores. They understand memory. They understand bytes. Hence, don't talk about like cost alone, but think about how do you explain cost in terms of what the what kind of I mean, whom you're addressing that to, right? So when you want to talk numbers in dollars, finance is a team. But when you talk to engineers, then you have to translate that cost to cores utilized by that team, memory utilized by that team. And that is how you start building the bridge between what finance wants and what engineering should deliver. Which then brings me to unit economics. So the ChatGPT School of Economics tells me that unit metric or unit economics is basically a representation of the rate of change for a demand driver, right? So what does it mean? So I was working for a company called Flipkart, which is one of the largest e-commerce arms of Walmart globally. Orders is what they track, number of orders delivered in a day, right? So for them, the cost metric could be cost per orders. Now, as soon as you start explaining a metric in this sense, that, hey, my cost per order is X cents, right? Then then it becomes a true bridge between what finance understands and what you need to deliver. Because now you could kind of translate that, hey, I am serving X 100,000, or I'm like generating X 100,000 orders in a day, and to kind of manage that kind of system, how much compute do I require? What is the kind of database that I need to use? And at the same time, the finance team knows, like, hey, what is it that we need to track? So today in our company, leadership meetings, we don't like track cost alone. We track cost per DAO, which is for us is daily active users, right? So don't just track cost, don't just track compute or cores or memory. Track, create a metric that works for you, right? Create a metric. It could be cost per DAO, cost per orders, cost per cores, cost what matters to business. That is basically unit economics in the cloud world. And if you kind of get this right, then you will be able to translate what the finance team or the business team is trying to achieve through the goals that they have versus what you need to deliver. So yeah, so I've talked a lot about the cultural changes, and cost optimization projects are not like a one night stand, right? Like you just like one and done, right? It's kind of a marriage that needs to be worked upon every single day. It takes a lot of hard work, it takes a lot of effort, but then there's a path to it, right? There's a path to keep the love and spark on for a long romance. So I talked about the cultural aspect that we had to drive in the company which helped us start this journey. Now let me like spend a little more time on what are the technical things that we did. If you have used Kubernetes in production, you would have come across the concept of wastage, right? And if not, let me like do a quick primer on that. So typically in cloud, you spin up a VM virtual machine, right? You get like, I don't know, some standard configuration. It could be 1:2, 1:4, 1:8, or sometimes custom. But then you get a standard virtual machine on which you will spin your Kubernetes pods, right? So assume that you spin up a 8-core 16 GB machine, right? And then you assume that all your pod, which is the one unit of your deployment of a particular service, is equally configured. So say if you were to run a 2-core 4 GB pod on a 8-core 16 GB machine, you get a very nice no wastage solution, which is all your cores are efficiently getting utilized. But again, 80-20 Pareto, right? There is no uniformity. Someone will create a service that needs more compute but less memory, not in the 1:2 ratio. For example, or someone could like need more memory and less cores, right? So you get a bunch of very sparse, very kind of very variety of workloads in your production systems, right? So imagine a situation where you have service say running with 5 pods, each requiring 2 cores and 4 GB, and then you have a small service which needs like maybe like 1 core 0.5 GB RAM, and then you have a fat service which needs like 3 cores and 3 GB RAM. So you have got a bunch of variety. Now, as soon as you have done this, now to consume 13 cores in our example, right? Did I get that right? 10 plus 3 plus 13.5. You have now spun up 16 cores of virtual machine. It means that there's wastage, right? No matter how you try to spin it up, there will always be wastage. This is what like the standard cloud offering provides, right? You spin up Kubernetes, quick, easy to deploy. You just set up a GKE cluster or a AKS cluster, and then you start deploying a bunch of services, and suddenly you have huge amount of wastage. Now, this is a very small example. Now bring all your services together. 100,000 codes, you can imagine the amount of wastage that you will run into, right? So the solution, right? So now, like, there are open source solutions like Carpenter, there are cloud specific solutions like GKE, Autopilot, and then there are like commercial solutions, enterprise solutions like Cast and ScaleOps that are trying to optimize this on through a variety of techniques. For example, they do things like bin packing. As soon as your bunch of pods comes up and they realize that there is a bit of inefficiency, they will run their algorithms to figure out what is the right mechanism, right bin packing that needs to be done, which pod needs to be co-located. In our example, for example, they will co-locate the four pods of equal sized, and they will co-locate the three invariant ones into two different virtual machines and ask Kubernetes to spin up a VM of that particular size. Now, this means that you no longer have the large wastage. You now are running with a much smaller Kubernetes workload. And as soon as kind of extrapolated to your huge scale, this becomes literally for us, it was millions of dollars of savings as soon as we started using some of these techniques. They also do things like spot prioritization. So in cloud, spot machines are always much cheaper than like running on-demand ones. So they will do things like scavenge spot machines for you, right? So as soon as a spot machine becomes available, they will preempt a on-demand node and then move your workload to the spot machine, thus saving a bunch of cost for you. These are solutions that are non-trivial to build and maintain, and companies like us, ScaleOps, are doing a great job in making that available to every customer that are out there. Cross zone, like the kryptonite to the Superman, right? So every database, every messaging queue, every solution that ever got built, which works at a good consistency, which offers like high levels of availability and performance, will run on a standard, like we heard about raft consensus and other things, right? So all these things mean that you run in typically multiple zones, so that even if one of the zones go down, you don't lose availability. There's enough redundancy always. But then that means that you start paying interzone egress cost. 3 or 4 years ago, interzone egress cost was not a cost in any of the cloud. Today, that's one of the major cost drivers for most of the big scale companies. So this is a standard diagram of like how a service running in 3 different zones will like probably interact over a database, right? So you have service A, service B, service C trying to access a particular data whose leader is in zone A, and basically B and C are the copies of that data, right? So whenever a request comes, service A, B, and C will always make a cross-zone request to zone A, except for the A zone service deployed. And then, because there will be three-way replication, that database update or insert will then again spread to towards the zones, right? So it means that for every gigabyte of transfer, you're paying like close to maybe 5x, and depending upon the reads, even more, right? So therefore, it's kind of a no-brainer that eventually, if you are running in multiple zones, interzone egress cost, and if you're running in multiple regions, then inter-region egress cost becomes the biggest cost line item in any of the cloud bills, right? Second thing is that, as I was saying, usage never translates in cloud to actual cost, because the way measurement is done by all the cloud providers and the observability that they provide is very, very different. Observability is provided on sample data, whereas the measurement that they do is much more granular data. So you were never able to translate the usage to actual cost, right? Finally, it's impossible to know which, like whenever you're running in a shared environment, it is almost impossible to know which service led to the cost of the interzone, right? It's impossible. We have tried a bunch of things. Unless you do things like eBPF level network observability and then tying it to the cost, it's all, I mean, there's no other solution. But then, as soon as you put like things at the networking layer, then it means that there are chances that you're trying to impact the performance of the application. So you like think twice or thrice before even thinking about deploying such a solution. So then this led to a bunch of other solutions that we looked into. So for example, in Kubernetes, there's something called topology-aware routing. If you're running with just one Kubernetes cluster, maybe a simple configuration like turning on the topology mode will make all your calls within the cluster go. I mean, if service A is calling service B, and each of them are deployed over 3 zones, then topology-aware routing in Kubernetes allows service B pods to be discovered by service A pods and therefore routed to that traffic. It works on a heuristic-based algorithm, and therefore and there is also like there's an imbalance, so load balancing needs to be maintained. So it works best effort basis, and but it kind of helps in reducing the cost down. So if your workload is in a single cluster, great. I mean, this is an easy probably option to enter into. But typically, large-scale deployments don't run in one Kubernetes cluster alone because you don't want to overwhelm the master node. So now you deploy multiple Kubernetes clusters. So then that means that when traffic needs to leave one cluster to another cluster, you have to pay the interzone traffic cost for sure, because there is no solution that works across clusters. You also now have to pay intra-load balancing cost. So all these Kubernetes clusters, whenever you deploy a service, they have a concept of an ingress controller. And with ingress controllers, they have a load balancer attached to it. So with that, you also pay to your cloud provider load balancing charges on traffic which is originating within the within your environment, right? So not the north-south traffic, but the east-west traffic. So what's the solution? Solution is kind of hard to maintain, but the only solution there is use a service mesh. So things like deploy Istio or Envoy, and then maintain large-scale Istio and Envoy deployments, which works either in sidecar manner or like now there's a concept of an ambient mesh. But there are these technologies that helps you overcome this, overcome the cross-cluster solution. So we kind of picked up on the vanilla Envoy developed by and then deployed that, and through that for us this is a solution that we use to manage our interzone networking cost. Finally, for databases, there are things like topology-aware database clients, right? So if you have used like Kafka or like ScyllaDB or any of these technologies, so most of them come with a knob called follower fetch or shard aware client, right? So that means that whenever a client connects to a particular database, in ScyllaDB's case, client will know you are originated in say zone A, and which is the replica that is having the data in the same zone, and will route the traffic, your write traffic through that. So in the original diagram that I had shown, instead of every service trying to hit one zone, you can actually now spread your load through in each zone, right? Then there are Kafka API solutions like Red Panda, then WarpStream, which have developed technologies which bypasses the entire interzone cost altogether by using storage first database, storage first solutions, right? So they will have the nodes across maybe in all the 3 zones, but then for replication, they only will replicate either the metadata in Red Panda's case, or if it's stateless, where WarpStream directly kind of pushes the data to the S3 or GCS storage. There are trade-offs to be maintained, and that's something that like every optimization journey goes through. So you will like either choose low latency or if you're okay with latency, then so as per the needs of your application, you can choose a solution that we want. Similarly, on databases, there are like newer set of technologies that are being built as cloud storage first, right? So everyone has suddenly like kind of come to epiphany that, hey, cloud storage is something that is durable, like durability was always guaranteed. They internally replicate across multiple zones. They give, I mean, the latency is the only true problem statement that the cloud storage has. So there are a bunch of use cases that can actually leverage and just be built out of a cloud storage first database. So things like vector database engine called TurboWoofer has built a similar technology. Postgres also has a, I think it's called Neon, or I'm just messing up the name. So Postgres also has come with a variant which does cloud storage first Postgres compliant database. So a lot of new technologies are coming up that kind of is solving the problem of interzone traffic through application solutions themselves. So I talked about Kubernetes, I talked about the infrastructure, but then databases always constitutes a tremendous amount of cloud computing. Like in all your builds, databases or messaging queues will always come as one of the top items in the list. Uh, there's a hotspot, something coming up, so just one sec. Okay. Sorry, something. Cool. So we talked about today SkylarDB. We talked. I mean, people spoke about SkylarDB. People spoke about Dragonfly, Red Panda. We have using all three, by the way. We also use DuckDB in production. So why did we choose all these databases? Uh, It's a no-brainer, right? Like the solution that they have implemented, thread per code design, shared nothing architecture, zero copy, C++ native implementation, vertical scaling optimizations. These are the technologies that people have now developed today, which was so far not available to us for large scale production deployments. When you run Apache Kafka cluster, right, it means that you're running a JVM based, limited CPU utilization based cluster, right? No matter like how fast it is, it will never be able to saturate compute on the brokers. This is where Red Panda comes in and is able to crank up the utilization of CPU to up to 80-85% without performance degradation. And then in the database world, similar to what I spoke about in messaging world, you have SkylarDB and Dragonfly, which have built on a very, very similar principle of shared nothing architecture, really driving up the CPU utilization, memory utilization to almost like, insane, very close levels of 80-90%, right? And these systems running at 80-90% of CPU utilization is incredibly hard to maintain and manage. You don't want to do it on your own, and that is where like these databases help us. By the way, I was not asked to put this slide by the organizers. This is something that organically came up because it worked for us. Over the last 2 years, we have used all these technologies, and these have been some of the key drivers in bringing our costs down. So thanks, guys. This really helped. Yeah, so we talked about the technical excellence that drove this, right? So how do you ensure that it becomes sustainable, right? So cost training, right? So what we do today is that whenever an engineer joins up, apart from all the other documentation that he goes to understand, like the service, the product, the domain, cost training is one of the key things that she also learns in our company today. Single pane of observability. We have finance guys and the engineers looking at the same observability dashboard and understanding from it. We don't have different panes of observability for different teams. Cost ROI as a non-functional requirement. Every feature that we build today has to have a lens of the return of investment that it is bringing in. So if you ship something that costs $100, but it only brings you $10, that feature is never getting shipped, right? So we've built this cost ROI framework that every feature, when in experiment mode, has to be observed. And apart from bringing the user engagement or ad revenue, they also have to bring in cost into the experiment decision and then only scale up. Efficiency game days, right? So as I said, that the journey is not like once and done, right? You have to continually find improvements on it. And this is where we run efficiency game days, where every time you build a much more efficient application. You're not only improving the performance of the application, but you're also reducing the cost. It means that you don't need to spend the same amount of dollars for what you were doing before. So always look for like more optimizations because technology continuously evolves. Yep. So, yeah, thanks, guys. So, yeah, I think in case this was interesting, I would really suggest that you could maybe borrow some of the principles and start applying them in your production workloads today and start seeing the difference immediately.
Great talk. I'd love for you to elaborate a little bit more on both the cost training and then the cost ROI portion. There's one idea I'd love to bring into my shop. So if you can help us understand how you made that real in your org and what it looks like, maybe a little bit detail.
So the question was like, if you could elaborate a bit more on cost training and what was the second one, sorry? Cost ROI. Yeah. So on cost training, like what we do in our organization, and like may work, may not work for everyone out there, is like whenever you onboard any engineer, like what do? You take them through your code repositories. You tell them this is where your dashboards, observability dashboards are. You tell them like the business metrics, etc. Right? But we just don't stop at that. Right? We make them aware of what's the cost of run of your application. So as I talked about the hierarchy, right? So you own or manage a particular service that belongs to a particular pod, team, domain. So the entire hierarchy is kind of done as part of the initial onboarding itself. And cost dashboards today, for example, when we monitor our internal traffic, cost dashboards today are as much used as our observability dashboards, right? So we have made like these dashboards as part of the daily, part of the daily ecosystem for all engineers, and not just engineers, right? As I was saying that, like you need to have a single pane of observability. You cannot have like data, like the finance guy is seeing something else, and then the engineering team seeing something different, right? So we ensure that everyone looks on the same data, becomes the source of truth, and therefore everyone being comfortable on what they're talking about, right? So you don't have like different dashboards and different data sets for different set of people. So that's how we are going about it. On the cost ROI, so as I was saying that, so typically in our business review meetings, we have made it a point that we on a weekly basis, the entire leadership looks into cost, but not just cost alone, but like what's the metrics around that we're also like for example, we look into daily active users, right? We look into monthly active users, we look into time spent. So we also kind of have metrics around cost per DAO, cost per time spent, and things like that, right? So when it becomes part of a weekly review from top down, then it kind of starts funneling down to everyone, because in those numbers, whenever they kind of go off the trajectory, it's like, for example, just like how you treat a P0 outage when your application goes down, we have done the same thing with cost. If the cost bumps up by 5%, it's a P0 outage. Someone has to look into it and solve for it. So that's how like we've changed the way we operate, and then kind of ensure that we run it sustainably. Because as soon as you take the foot off the pedal, right, like things again blow up, right? And so these are the changes that we have to do. We have also done as within our company to ensure that this kind of works on a sustainable manner.
Yeah. We have time for one more question, and then the rest of them get asked at the happy hour.
Awesome.
Last question.
The use cases you just presented to me seem after the fact. Do you do anything maybe during the tech design phase to try and establish a cost to ROI? Like, do they break down the cost of a feature they're planning to build?
Yep. So in our experience, we realize that predicting cost is very, very hard, right? So when people build product, they think that it'll have a certain scale, but it may or may not happen. It may either surpass your expectations, or it may does not meet your expectations. So you never know, like in a consumer facing internet application kind of world, what works and what doesn't work. So you typically do experiments, right? So we don't do a lot of we don't do like a cost review in the design phase, because at that point in time you really don't know. As I was saying, like you could write a horrible code, but if it doesn't get used in production a lot, then it doesn't cost, right? So what we do is that basically during the experiment phase is when we start understanding cost. It means that we have rolled out the change to, say, a small sliver of production traffic. Now, against that, we are measuring our other objectives, but then we are also measuring the cost objectives. And that is when we come back and say that, hey, to scale this, at 1%, it hasn't hit us. But when you scale it to 100%, the cost will balloon up badly. And therefore, you need to, before you ship it to 100%, you need to kind of optimize it further. So that is what has been working for us, because predicting and staging is, we tried it, but it never really worked. Okay, thanks guys. I'm here. Let's enjoy our drinks and then we can catch up more. Thank you.